and welcome back to Jumanji. In the previous video, we're talking about the alpha halogenation of enols and enolate, and we selected this methyl ketone as a starting material for your carboxylic acid product here. We said methyl ketones, once treated with excess hydroxide and excess halogen, produces carboxylic acid. Your first step is going to be your deprotonation of one of your acidic proton from your alpha carbon here, right? Leaving behind a negative charge and a lone pair. We're using your solid one-headed arrow because this reaction will be irreversible because your base is so strong. Once you have your lone pair nucleophile here, which can then attack your halogen, forming this next intermediate here, right? It's good to note that this is your enolate form, where this lone pair can do resonance, putting the double bond on your pipe CC here, right, and your negative charge on your oxygen, and that would be your major resonance form. But in this case, we're using your minor resonance form and attacking from your carbon here, right? Your intermediate will look like this. Now we said that this was an acidic group, right? That's on the special function of your ketone, is it has that alpha carbon that has acidic proton. Now imagine replacing this hydrogen with a bromine that can better stabilize any negative charge on this carbon here, right? This will be even more acidic than this compound here, right? Again, your hydroxide can come in and deprotonate the next hydrogen, leave behind a lone pair again, which can attack another molecule of your bromine, that excess bromine we're talking about, replacing this next hydrogen, and again replacing this next hydrogen, right? Once we have your CXXX, we have a moderate to good leaving group, right? And we also have an electrophilic carbon here, and we still have that excess hydroxide floating around, right? That can then come in again, attacking your electrophilic carbon here, kicking up a pi bond to your oxygen and forming a tetrahedral intermediate. It's also good to know that carbonyl compound with halogens attached go through tetrahedral intermediate, which looks like this. One of the characteristics of tetrahedral intermediate is that they collapse on themselves, right? Collapses, kicking off your CX3 leaving group. Once this leaves, this is not your final product, even though it looks like it, right? Because we still have that with a negative charge floating around, right? Which can then come in and deprotonate this hydrogen again, leaving your oxygen with a negative charge, and in comes your weak acid to do your final workup, giving you your final product.